There you go.
You got like a couple more cameras. You just have like different angles.
All right, you still want a static, right?
Yeah.
Yes.
Yeah.
So quizzes are messed up. The date you plan for it. What date you have, all right?
All right.
I don't have my glasses. Is it okay if I sit up there?
Sure.
Because I can't see.
You can get one.
Okay. Anywhere you want.
Okay.
All right, so let's talk about static quickly. So static, a method which is static, like public static, void, test, for example. I don't write the implementation, but you can implement anything, right? If this method is static, it means it's bound to this class. It has nothing to do with an object. So can I call this method using the class name here? Yes. So I can come here and say what? Public static void main. Main is also static, right?
Yeah.
Right. String arg. Now, if this is static, this is test. Can I call it here just like test?
No, you use your Chap10. You have to.
Yeah, you can.
I can call it. Or if you want, you can put the name here too. Or actually, I have one main here already. So I can put it here, right?
Yes.
With the dot two. The same, right?
Yes.
Now, if I remove this static from here, will that work?
No.
Because it needs to be represented. It needs to be attached to it.
No, it does not work anymore. Why? Because I need an object to access this. I need an object to access it in a static method.
Yes.
If it's a non-static method, let's say I create another method. Test two. Two methods, right? They are not static, they are instance, right? Can I call this inside this?
Yes. Yes.
You have that, right?
Yes.
I can. But not inside this one, right?
Because that's a static.
No, yeah.
Because that's a static one, right? And I told you the reason for it, because this is a static, which means it's not bound to an object. But this one is bound to an object, right? So when I call this inside this, it doesn't make sense. Because this is bound to an object, this is not bound to an object. So how can I call something that is bound to an object from something that is not bound to an object?
Third time. I get it this time, I swear.
Does it make sense? Yes.
So you're saying if it's static, we have to call it, we'll call it like chapter, or yeah, chapter.
What, this one?
Yeah.
You can't call it. If it's a static or not static. Are you talking about this example? This example, it will not work. Why? Because this main is not bound to an object. I can call it through class, right? Then inside that I'm calling something that is related to an object. How that's possible? You need some object inside that. Can I create an object of this class and call the test?
Yes.
Yes, that you can do that. Yes, I can come here and say, create an object for me, obj1. And can I use the default constructor?
Yeah.
Yes. Now, can I use this obj1 and then call this test? Yes, we can now. Because now it's associated to an object, even though it's inside a static method, right?
In line 15, why does that, what's the reason behind?
Because is that an instance?
Yes.
Do I need an object to access this?
Yes.
When I create that object is calling this one.
Oh, I see.
You see that? I can't call this without an object. So when I create an object and I call this one is also associated to the same object that is calling this one. So it makes sense.
But
Right?
where's the object being created?
I did not create yet.
It doesn't matter. It's just because it needs an object, it's saying, okay, this is fine.
See?
Object is to create.
Look at this one.
Yeah.
Look at this one. Am I calling the test?
Yes.
Yes. Can I call it test 2? Yes. So when I call test 2, will that object calling this? Yes. Who is calling this one? That's object one again, right?
Okay.
Alright. So static, you don't need an object. Non-static, you need an object. I cannot call a static method, a non-static method inside a static method. Directly, right? Can I access static instance variable inside a static method? Yes.
You have to
Yeah,
you have to do an object. Ah.
Yeah, you have to go to the object again, because if I come here and say, let's say private int radius, for example. Just for an example, right? Can I come here and say radius equals 5?
No.
No, because which radius I'm talking about? It's this one doesn't need an object. So when I call main chapter 01_1 main, that radius is associated with which object? No object, right? So I cannot call radius equals to 5. It will not work. Now inside that, can I create an object of this chapter and then access radius?
Yes.
Yes, you can. Make sense? Yes. Oh,
Stand
The
up.
whole dot just look over.
Good job. Better? Alright, so we good with this?
Yes.
Alright, let's keep going. Did you have a quiz last week?
No.
We had a.
Not last week, 2 weeks ago, yeah. No, we did not have a quiz last week.
What?
It was really.
Oh, yeah, what?
1 week.
Alright, my bad. I don't know why you pulled
It's all
off.
good, man.
You understand.
2 weeks ago, we had a quiz. That was the last quiz. Yes.
Alright, so we talked about all this stuff.
We stopped off at parent is inherited except constructors and was it?
Oh, so we went to inheritance, you're right.
Yeah, we're on chapter 11.
Yeah, you're right. I said I'm gonna cover inheritance again from the beginning, right?
Yes.
Alright,
Yeah.
so inheritance, what is the key word? Extend.
Oh, extend.
So you have a class, like let's say geometric object, you have a circle class, you have rectangle class. These two classes are inheriting everything from geometric object, and the reason for inheritance is you don't want to rewrite everything from this class inside this class again. You want to say everything that extends from this will inherit everything. So, superclass constructors, are they inherited? Superclasses, constructors
No.
from superclass.
No.
They are not inherited, right? But everything else is inherited except the
The-
private stuff.
Yeah.
So if something is private to parent, you're not going to inherit that. You good?
Yeah.
The constructor is not inherited, and private stuff is not inherited. Anything else, we're going to get inherited, right? Okay? Now, let me show you the game cat and blah blah blah. So we have animal. Animal has two strings as property. You have name and color, right?
Yes.
And then you have setters and getters. Now, cat, again, it is depending to your business logic. You want to apply inheritance or no? If it makes sense, apply it, alright? There is no technical stuff here. So cat, when I create a cat, do you want to inherit everything from animal or no?
Yes.
Yes.
Yes. So I'm going to create a cat, and see here, I'm going to say what? It extends from animal. Obviously, cat will have what? Maybe some more properties, right?
Right.
We discussed it last time, and we got to this conclusion, stripes with one property, right?
Stripes, yeah.
If the cat doesn't have any extra property, for example, does it make sense to extend from animal?
No.
No. Because the cat will be the animal, right?
Right.
So the reason you extend is this new class will have some more stuff, and it has all the parent stuff too.
Right.
Alright?
Yeah.
That makes sense, right?
Mhm.
Alright, so stripes, and then I created an animal here.
So now cat has 3 instance variables.
Yes, cat will have 3, no, actually cat will not have 3 instance variables because these are private.
So just one.
Just one, but it has access to what? Setters and getters. Right? Because setters and getters are public, right?
Yes.
So it has 3 property but not really directly. You agree? It has 3 property but not directly.
Not directly.
Not directly.
Yeah.
So are we good? You can't access them directly because they're private, right? So let's take a look here. Did I create a cat, an animal? Yes. Is C1 also an animal?
Yes.
Yes.
Yeah. So let's say C1. Will I see all those getters and setters?
Yes.
Yes. And do I see the stripes too?
Yes.
Stripes, right? So are we good with this?
Yes.
And of course this is a private, so maybe I want to make it setters and getters for that one too, right? Is stripe, set stripe, alright?
Yes.
When it's a boolean, it doesn't say get, it say is. Are we good? Alright, now I said I want to create another one, dog. And dog also extends from animal, you can add some more here. And wildcat. Wildcat is extending from cat. Maybe you want to add a property to it. What property you want?
Does it have claws?
Long
claws. Stronger?
Just say it's a pharaoh. It's pharaoh.
Huh?
Bully.
Boolean is definite.
Bully. We'll kill you. We'll kill
Fat,
you.
fat, put fat. The fat cat or not.
Just put
Put
very
fat.
wild.
But fat can be applied to cat too, right?
Oh, yeah.
But I want to, right? So it should be specific to this. Alright, it's deadly. I'll go with that. Alright, it's deadly. So wildcat will have what? Will have everything that cat has, everything that animal has, and also some property that is specific to the wildcat. Are we good with this?
Right.
So it's easy concept, right?
So the animals are coming indirect parent class, right?
Animals what?
From an indirect parent class.
I think cat would
No,
be
cat is a direct parent of wildcat.
Right.
Animal is indirect parent.
So at this point, is cat parent?
Which one?
So cat becomes the parent class?
Cat
Extended?
becomes direct parent class.
Direct?
Direct. Because animal is also parent, but indirect.
So it's like animal, cat, and wildcat.
Correct. So are we good?
Yes.
Alright. Now, let's go through the slides. Okay, so super. Yes.
Yeah, you're about to go through it, but I was just reading that and it just said they're not here, but does it, when you use your constructor for your child, it implicitly just doesn't, you don't have to.
Yeah, if you let me go through this, I will explain.
I know, that's what I was like, you're about to do it, so I'm gonna just shut up, because you,
Alright, so we have, let's talk about super. Super is very important. Everybody know this? Everybody remember this?
Yes.
Keyword this?
Yes.
Yeah, keyword this.
Yes.
It relates specifically to the property function.
It relates to the local variable instead of the instance variable.
Yeah, it's
Other way around.
it's local
It's
to
the
the
instance variable.
specific.
Yes, it's very instead of the local.
Alright, so everybody remember this?
How about this? It relates to the object
Alright,
instead of.
hold on, hold on. Everybody remember keyword this?
Yes.
Yes.
How many usage we had for this?
2.
For the
Yeah.
Okay.
constructor,
One was accessing what? The properties or even methods, right?
Yes.
And one was calling the constructor. It was the constructor, right? And we use it for constructor
Overload.
chaining.
Chaining, yeah. Is it?
Constructor chaining.
So that's
One constructor calls the other one. Alright? Now let's talk about super keyword. So we have keyword super. Alright? So I'm going to give you an example of how super works here. Super can be of 2 usage again here. But whenever you say super, it's related to what? To super class. Okay? So, first usage of super. Let's take a look here.
Actually, you think real quick before you can I ask you this? So when you're using this to call a constructor, is it to call a constructor that might be present in the parent class and the subclass? Well,
It's only inside the same class.
only inside the same class.
Yeah.
No, I'm saying though, would you use it because it might be a constructor inside the parent class that has the same name as a constructor inside of the subclass?
You can't have the same name, right?
Oh, you can't. So what's the point of using this for a constructor?
So if you want a default variable or something.
Inside of your constructor, then, so really using this.
Are you talking about constructor usage of
Yeah,
it?
yeah, constructor usage
Alright.
of this. What's the point of
The
it?
usage is because you have more than one constructor and one constructor wants to call the other one.
So you have to refer to this specific.
Public animal. Is that a constructor?
Right.
Alright. So, can I come here and say name equals not applicable and color is not applicable?
Right.
Do you agree?
Mhm.
Alright, can I have another constructor to say string name and string color? Come here and say two constructors, right?
Right.
So the first one, name and color, will be not applicable. If I use the second one, I have to pass two arguments to
Right.
set the name and the color, right?
Right.
Alright, now I do a chaining here. I'm not gonna put this here. I'm gonna come here and say what? This, not applicable. So if I use the first constructor, what will happen inside the first constructor? It calls the second constructor and pass NA and NA to it. So I change the constructor.
You said it calls a second constructor?
Yes.
Okay.
Because this, we call a constructor
With those arguments?
with those arguments.
Okay.
If you delete one of those arguments,
It will not work.
it won't?
No, because you don't have a constructor with one argument.
Okay, so as soon as you delete it, it'll like show up as an error?
Yeah, as soon as I delete, it says I don't find a constructor with one argument,
Gotcha.
unless you implement one.
I see.
Are we good?
Mhm.
With this?
Leave it up on the board for like,
What happened?
just leave it on the board.
Just leave it on.
Leave it. Good?
Mhm.
Right, so let's just, now take a look here. Let me go to the cat here. Super is a keyword. It has two usage again, alright? Let's take a look here. If I say here super dot, I can access at any any property that is accessible in the parent or any method that is accessible in the parent. Set color, can I access it?
Yeah.
Belongs to who?
The parent animal.
Animal, the parent, right?
Right.
Now, can I use set color here? Again?
No.
Yes, I can.
It's implicit in false.
Oh wait, is it because we were?
See, set color coming from who?
The parent.
Then I say the child will inherit everything.
Okay.
It comes from parent, right?
Yeah, yeah, yeah.
Set color. Can I come here and say green?
Yeah.
I can, right?
Yeah.
Before I set the stripes to true or false, I change the color to, for example. Can I do that? Yes, because do I have set color in this class? No. But should I go to the parent and see if it's coming from the parent?
Yes.
Yes, and it's coming from the parent. Now, instead of saying, hey, come from parent, you still say, you can say super dot. It means use the parent one.
Right.
Even if you don't put it, it gets it from the parent, right?
Okay.
Because it doesn't find it here, right? Now, this makes a difference when you have a set color inside this class too, right?
Isn't that overriding?
If you have a set color in this class, If you say set color, which one gets used?
One in the
The
class.
one in the class. But if you say super, which one gets used?
Parent class.
From the parent. So this case you need to say it needs super or it doesn't need super. But in our case right now, does it make any difference if I say super or not super? No.
But if we were in a separate class that's extended from the animal class, then it's pulling that method from the animal class, right?
Yes. If you say super means go to parent and find the set color from the parent. But because we don't have set color in this class anyway, even if I don't put set color, it goes to the parent and tries to find it there.
Because of the extent.
Yes, but if I did have a set color in the same class, then with super it says go to parent and find it. Don't find it here anymore. Make sense?
Is that any sense of overriding or over? That's something else.
Nothing to do with that. It has something to do with that, but not right now.
Not right now. I'm gonna stop. Should we just-
Alright, we good?
Yeah.
So one usage of super is what? Accessing the property or the method of the super class. Is it like this but for super class?
Yes.
Right.
Yes, it's exactly like this but for the super class. Does it make sense?
Yes.
Now another usage of super. If you use super, let me have a cat constructor here.
No, we need a
Public cat. If I use super here, and I can use only super with this parenthesis inside the constructor, right? I cannot use super method in any other method, just constructor. When I say super like this, you know what it means? It means call the constructor of the super class
To create another animal.
to create an animal. Right. So if I use super with parentheses, it means it's what? It's a method. I can only use it what? Inside the constructor, and it means go to the parent and trigger the constructor of the parent with no argument. Because there is no argument here, right? Are we good? Is that like this again for super class? Yes, because this will call the constructor for the same class. If you say super, it calls what? The constructor of the parent. So they are similar, but one is for the same class, one is for what? For the parent class. Are we good? Super. And this? These are all questions they're going to ask you in the interview, alright? This, super, constructor chaining. Now, this is very important to understand, and it's a bit tricky, so let's take a look. Use your common sense first. Who was created first, your parent or you? Alright, that's the case in Java too, alright? So it's gonna create the parent first, and then it's gonna create what? The child. So take a look here. Did I create a cat here? What? Animal is the parent of the cat, right? So I have to create animal first, and then I have to create a cat. Now take a look here. Will this trigger the constructor of cat here?
Right.
I don't see any animal gets created, right?
No.
But Java implicitly is creating an animal for you. How? Whenever you have a constructor that has a parent class, a super keyword with no argument is sitting there implicitly. So that is there, but you don't see it, but it's there. So if I put that there or don't put it there, does it make any difference? No. It's always there. So what that means now? This means go and create the parent class object, and then come back here and create this cat class. So super is always there if this class has what? A parent.
It's always the first thing when you're team.
What would be the name of the animal object?
There's no name for it.
It's just created, but there's no. But how can you access it?
It's just Java. It's just
Through the cat object.
Behind the scene outside, it creates an animal. You don't know who it is, but it gives you the cat. But you can't have the cat without the animal. Does it make sense?
Yeah.
So super is always there or no?
Always.
With no argument.
Always there.
Always there.
Always the very first thing he thinks of.
Alright?
Yeah.
So did you write this one? You
Yeah.
are in the context. It's easy to understand and answer my question. When you get out of the context, you forget this and you make a mistake. So
All right.
write this down and highlight it. Super is always the first statement in the constructor of what? Of a class that has a parent.
Right.
It
Good?
it cannot have any arguments, right?
The super can.
Yeah, right.
This one, it can have an argument. That's the other rules I'm going to talk about, alright? So, just be patient few minutes. So, do I have a super there? I do have a super, right? Everybody agree?
Yes.
Alright. Now, rule number 2. As soon as you put a super there, that default one is gone.
What default?
The invisible.
The invisible one is gone.
Same thing with the other constructors.
So, did I put a super here?
Right.
Did the default one gone?
Yes.
It's gone. Don't count on it. Huh? You can put argument, yes.
So meaning when you write super.
So can I put this?
The default argument?
Yes. Can I put this?
Yes.
Yes. So let's go to animal. Do I have any other option there too? Do I have this one option as an option?
Yes.
So can I come to the cat and I say, not applicable, for example, and not applicable. Can I write this one too? Yes, you can put any super keyword there with any argument that matches the super class constructor.
I see.
It should match because you have to create an animal. Now, you can do it explicitly like how I did, or you can leave it to Java. But if you leave it to Java, there's some limitation there. What is the limitation?
You can't access like anything specific.
What was the question again?
See, I can create the animal. I have to create the animal.
Right.
I cannot create a cat without an animal. So I have to call a super. I can do it explicitly, that's how I did. Or you can do it implicitly, leave it to Java. Java will do that, but there is a limitation here if I leave it to Java. What is the limitation?
If there's multiple constructors, you can only pick one.
If there's no default, if there's no
Only
default.
picks
It
one
only pick the
constructor,
empty.
the one with no argument.
Right.
And if there isn't one there,
That's the limitation, right?
Right.
If you leave it to Java, Java says the only thing I understand to put there for you implicitly is what? This one. I'm not going to do anything more. So if you want a constructor with argument,
You
you
gotta
have
do
to implement it yourself. Right? Java trying to help, right? But it's not unlimited help, right?
right?
It says I'm just going to put super with parentheses without any argument there. If it fits your need, that's fine. If it doesn't, do whatever you want.
Okay.
But super should be there implicitly or explicitly. Are we good? So what about this one? Where is the wildcat? Wildcat. Do I have a super here too?
Yes.
Yes.
But it's cat, not animal. It's still animal?
No.
It's cat. But it's gonna go into cat and then it's gonna go
So
into
do I have a super with no argument?
It's gonna
here?
go on the, it's gonna go on the,
It's gonna go
yeah.
to cat and it's
Yeah,
gonna go to
so again, because wildcat is a child class of a cat, you have a super implicitly sitting there. So this means I can't create a wildcat unless I create what?
A cat.
A cat, and I can't create a cat unless I create what? An animal. Then it comes back, it creates a cat, then it comes back and creates what? The wildcat.
You have to chains together.
It goes all the way up to the top.
So it's good?
Yeah.
Rule number 3.
First thing,
So you know the rule number 1. What is rule number 1?
It's always the
always-
super.
It always creates a no argument constructor for the parent.
yeah.
What was the rule number 1?
For
You wrote
super?
down. Yeah, for super.
It's always there.
It's implicitly there,
Right.
with no argument,
Right.
right?
Mhm.
Okay, rule number 2. What was the rule number 2?
Just one there.
It
Yeah.
kills the
As soon as you implement one, the default one is gone.
Right.
Rule number 2. Rule number 3. This and super doesn't come together in one constructor. And it makes sense. This and super doesn't come in one constructor together because you have to create a parent or you have to create the class you are in. You can't create both at the same time in one constructor, right? That's why when you have super, you don't have a this.
So you can't use this after using super.
No. Do I have super here?
You can't do this. You talking about this super. You can't do this dot super.
No. This as a constructor call.
Okay.
Super as a constructor call. I'm talking about super and this as a constructor call.
Mhm.
Do I have super here?
Yes.
Can I come here and put this? For example. Let's create a wildcat here. Our boolean. Alright, now take a look here. Do I have a super here?
Yes.
Can I have a this with true?
No.
I cannot. Super and this doesn't come together as a constructor call. You can have in one constructor super and this at the same time because you cannot create the parent at the same time the same thing together, alright? Only one. So, can I remove this?
Isn't it implicitly created already though?
It will implicitly create, but if you have a this, it will not create anymore.
Oh.
It only create if you don't have a this there. But do I have a this now here?
Yeah.
Do we have a super implicit there?
Yes.
No, we don't.
No, he just said it's on.
If you have a this, Java will say you have a this. Super and this cannot come together. I'm not going to give you an implicit super anymore.
Okay. This and super can't be together. Got you.
Huh? When it calls what? Yeah.
So it's gonna do it there.
So if it goes here,
Once you create a super,
do I have a super here? Do I have a super here or no? Super call.
Yes. No. No.
Why
no.
not?
Because this is there.
Huh?
Because this is
I
there.
don't.
You don't have a this constructor?
This
No.
as
Okay.
a-
Never mind. This constructor. I thought never mind. You do have one there. You do have one there.
This as a constructor call
Okay.
I'm talking about, not this as an access of a property. This as a constructor call does not come with super as a constructor call.
Alright.
Hey, you're not writing anything. You remember everything? No, behind you. You remember everything?
Oh, that's me.
Yeah, you.
I
You
got it.
remember everything?
I remember.
Okay.
I know everything.
Can you explain the third part of it again?
Which one?
Third part.
You can't have a this.
Super as a constructor call and this as a constructor call cannot come inside one constructor like this. They cannot come together. You have one of them, not both. Yes.
What does it mean if the this is there instead of the super?
Do you see a this here?
Yeah.
What it means?
That's what I'm asking. What does it mean?
It's calling the constructor that has the appropriate argument inside of the class.
So it would, okay.
This means it's calling the constructor of the same class with having one argument of a boolean. When you have this, you can't have the super anymore. We said, rule number 1, a super implicitly is there, but that's for the case you don't have a this constructor call. If you have it, that implicit one is gone. You don't even have the implicit one. Now if you try to be stubborn and put this one here, you get a compilation error. It says you can't have both. Got it?
Right.
So you only have the implicit one if you don't have the this. And when I'm talking about this here, it's a constructor call, not accessing the property or method. Are we good?
Yeah.
Okay, so
Now,
what's the third part? I got it.
which third part?
Of the super. Address this concept.
That was the third part. So you understand that this can call a constructor of the same class, right? So if that's present, then the super constructor call cannot be present. Only one of the constructor calls can be present. Either this or the super.
Okay,
That's
now-
the third part.
Right. So are we good?
Yeah.
So if I call wildcat, which I did here, what will happen?
It calls the second constructor that has a
Call
boolean.
this one.
Right. But that one has an implicit super constructor inside of it, right?
Yes.
Yeah.
Yes.
You got it.
So there is an implicit super here, right? Because this is a parent class, it has a parent class, and you don't have an explicit constructor called this, right? Then there is a super here. So there is an implicit super here.
So at that point, does it create a cat and an animal?
Then it goes to the cat and tries to find a constructor that has no argument and creates that. So let's go to the cat. Which one matches? This one. And then comes here. Do I have explicit super here? So do I have implicit super? Not anymore. Because rule number 2. As soon as you implement one, the super default is gone. So now this super NaNA goes where? To animal. And with 2 arguments, right? Do I have one? So I assign NaNA here, I come back to the cat, and I come back to what? Wildcat.
So if you were to delete that first super that you created, then it would be another implicit.
Which super? Wildcat?
Yeah.
If I delete this,
No, wait, I was talking about animal class. If you deleted that.
I don't have a super in animal class. So are we good with this? So if I remove this, does it make any difference?
Nope.
Do we have still super there? Yes, you do. Alright? So even if I remove this, there is a super there.
So question, if you go back to animal, let's say you don't have a no argument constructor, it just goes to the next available constructor?
I have a no argument constructor.
What if you don't? Well, what if you don't?
They have a default in there.
Then you will get a compilation. But if you don't have it, because then the cat says, with no argument you said?
No,
Yeah.
For animal?
That's what I was trying
No,
to
for
say.
animal is fine. See here, wildcat, you're using this one to create, right? It calls this one. Do I have a super there? Yes. So it should go to the cat with constructor that has no argument. So let's go to the cat. Do I have a constructor with no argument?
Yes.
Then I call the constructor with 2 arguments of the what? Animal. Do I have a constructor of 2 arguments in the animal class?
Yes.
Yeah, this one. Do I have it?
Yeah.
So even if I remove this, it's okay.
It will go to that. Okay. As long as the cat's class.
Now if I
matches
remove
the
this
animal.
one, will it cause a problem?
Yes.
I see. Thank you.
Good?
Good.
Alright, again, not that difficult, you can forget it easily. So what? If you want to practice it tonight, you want to write notes, whatever you want to do. Or whatever you don't want to do. Alright, so we good? So take a look here. Let's say A is extending from a class. Do I have a super there?
Yes.
Implicit is there, so these 2 are the same, right? Again, a constructor of A. Do I have a super there again?
Yes.
All the constructor will have a super, unless there is a this there. Then you don't have that super there, alright? This has a constructor call, right? The keyword super refers to the superclass of the class in which super appears. This keyword can be used in 2 ways. To call a superclass constructor, to call a superclass method. Do we agree with these 2 statements? Why it didn't say it's to access a superclass property?
Because you can access properties throughout the constructor.
That's the case, but all the time the properties are what?
Private.
Private. So that's why you cannot access it, right? But if you make it public, can you access it? Yes. But you should not. That's why it dropped that part, right?
So with superclass, even if it was private, you can still use it, right?
Superclass what?
So with superclass, like if the parent is private, you can still use it.
What
right?
that means, parent is private.
The data field class.
Oh, you mean the property?
Yeah, the
Properties
property.
are private? Can you access it through the child class, you mean?
Yes. Superclass.
Yeah, superclass. It's nothing to do with superclass. If you have private properties, if you are inside the same class, can you use those properties?
Yeah. But if you were in a separate class, would you be? But it's private. No matter what, it's private.
Yeah, it's private. Private to outsider, including the children. All right. Can you access everything your parents have? No.
They don't think that. When they're liquor cabinet.
All right, we good?
23.
All right, let's not go to too much detail. All right, you must use the keyword super to call the superclass constructor. Invoking a superclass constructor's name in a subclass causes a syntax error. Java requires that the statement that uses the keyword super appears first in the constructor. Oh, I forgot the rule number.
Yeah, no, I was like, you're still missing one.
I missed this rule, so maybe you can add that. Let's look at the cat. Or let's look at the wildcat. So do I have a super here? Yes, I do, right? Is that okay to you?
Yeah.
If you want to put explicit super there, that should be the first statement in the constructor. And it makes sense. Why? Because first you have to create the cat, then you say create the wildcat and do some stuff to the wildcat. So this should be the first thing. So if you remove this and put it here, it will not work. Child class will say immediately create the parent. This is not immediately create the parent. Doing something to the child, which the child does not exist yet, right? Then create the parent. But if you remove it, you're safe, right? Because Java knows where to put that implicitly, right? Are we good?
Yes, sir.
All right.
Would you create an explicit superclass, like in a real world situation? Because that explicit implicit kind of
You seem to what?
seems extra.
Extra.
I mean, if you're passing arguments, you're gonna leave that this over there. You're not.
There's nothing extra. We're going to see the example. All right. Good question for exam.
Alright, cool. Awesome.
Let's go through it. Public class faculty extends employee. Now, did I talk about that we can have more than one class in one file?
Yes.
But only one can be what? Public, not method, public class. So you can have more than one class in a file. Only one can be public, right? And the class name will be what? The public class name. So if I put this in one file, which I have one class, another class, another class, what should be the file name? Faculty.java. So we good? So all these classes are in one file, but one of them is public. Public class faculty extends employee, which means employee is the parent of what? Faculty, right? I have a main method inside the faculty, which is fine, and I have a faculty constructor. Are we good? Faculty constructor does what? System out print 9 says faculty no our constructor is invoked. Are we good? Now I have a class employee which extends person. Do I have a constructor for employee? Yes. What it does? Calling the this and passing an argument and then printing something here. Employee has another constructor which accepts a string and prints that. So two constructors in employee, right? And the last one is class person, which doesn't extend from anything. it has a constructor with no argument and it prints something on the console. So do you agree faculty is the child of employee, employee is the child of the person, and person doesn't have any parent? Now, in the static, which is the starting of every Java code, right? When you run it, did I create an object of faculty?
Yes.
Of course, I didn't assign it to any variable, which is fine. So what will happen here? Do I have to go to the constructor of faculty with no argument and trigger that?
Right.
So should I go here?
Yeah.
What happens here?
It's gonna go to employee.
Because the super is there.
Do I have a super sitting here?
Yes.
Everybody agree?
Right.
Super with no argument?
Right.
So should I go to employee and find a constructor with no argument? Should I come here?
Mm.
Now, do I have a super here or no?
Yes.
Yeah.
Oh, you have this.
No, you have
No.
This
Constructor.
You have a this, so you don't have that super anymore. You call the this, which means the same constructor, the constructor of the same class, but passing one argument. Do I have one?
Yes.
Yes. So this string goes where?
Into there.
Goes here. Now, do I have a super here?
Yes.
Yes.
Yes, because I don't have a this, and this one has a parent, right?
Right.
So it means I have to go to the parent class and find the constructor with no argument and trigger that one. Do I have a super here?
No.
No, because person doesn't have a parent. So do I print this? Person no arg constructor is invoked. I print this one, right?
Right.
Where should I go back?
To the string, employee.
To the
string.
super that you called it, right? It was here, right?
Right.
Do I print this one now? Which was this string that I passed, right?
Mhm.
Invoke employees overloaded constructor. Now, from here, where should I go back? To the this that called that, right?
Right.
So I come here, right? System out print line employees no arg constructor is invoked. From here, where should I go back? To the faculty, because that one called that what? Super, right? And then I print what? Faculty no arg constructor is invoked.
Oh, 1, 2, 3.
Right?
That's
It's
tricky.
easier, it's easier once you practice it.
Yeah, yeah, I know.
It makes
So you have to just be careful. Do I have a super here or I don't have a super? That's the whole key. If you have a super here, you jump to the parent. If you don't have a super, you have a this there. And then you find the constructor of the same class and you go there. Again, you don't have a this here, so there is a super here. And you got here, there is no super here because this class what? Doesn't have a parent, right? We good?
Good.
This becomes difficult if you not be in the context. If 2 weeks passes, and I give you suddenly this, and you didn't study much, then you might mess it up.
This is coming.
It's gonna be on that quiz that I just study.
So we good with this?
It's good right now.
Alright. So let's see the flow one more time. Main is always the starting point. I call the faculty. Faculty constructor gets lost. There is a super there, right? There's a super here, right?
Right.
So I jump there. Employee. I don't have a super here because there is a this. So this, when this gets triggered, it jumps where?
To that.
Here. I have a super here because that has a parent and I don't have a this, right? So it jumps here. I don't have a super there anymore because I have no parent for the person. So this one gets triggered. Then it comes back, this one gets triggered. Then it goes back, this one gets triggered. And then it goes back, this one gets triggered. Got it?
Not yet, but eventually, yeah.
Okay.
No, but it makes sense, but it needs practice.
That's crazy.
It's not that bad. It's not.
Are we good? Again, this is in context is easy, but if I give it in the interview 3 months from now, an employer gives you, it becomes difficult. Will this compile or no? Or if its code is okay or no?
There's no argument constructor, there's an argument
But there's no argument constructor for.
fruit.
It would have to be apples for it to
You see-
execute, right?
Huh?
Would it have to be public apples for it to execute?
Public
Yeah,
apple?
yeah, because fruit
Sorry.
has no, it doesn't have a default constructor.
Inside,
Doesn't it like put one there or something, you know?
Huh?
Isn't there like the audit?
wait, no, it's because
It doesn't
you're.
have an argument.
Why Hold on. One by one. Tell me what you said.
Isn't there like
Isn't-
an automatic default constructor
Where?
in fruit? It doesn't have to put in
Fruit does not have default constructor because
Apple
Yes, it
has
is.
that.
as soon
I mean,
as-
I meant an apple.
Apple has a default constructor because you don't have an explicit constructor.
Right. So
It's trying to
does that
find-
constructor have a super in it?
To what?
Does that default constructor have a super in it?
Yes, because that's the rule. The first statement of any constructor is what?
Super.
So Apple has a default constructor, which you don't see that. But what is the first statement of that default constructor?
A no arg super.
An arg super.
But it's gonna have an error because it can't find one because fruit doesn't have it.
Fruit is listed after you're trying to call it, right? It doesn't exist yet.
That doesn't matter what class it is. It's trying to find the default constructor.
Correct. If I create an apple, I use the default constructor. That default constructor first statement is what? Super. So it jumps to the parent class to find a constructor on the parent class with no argument, right? Do I have a no argument constructor in fruit?
No.
Doesn't compile.
Is that runtime?
No, compile.
I'll compile
You good?
Yeah.
How can I fix it?
By adding a default constructor for fruit or adding a one argument, a string argument construct super for fruit. I mean for apple.
Right.
Yeah.
You can add default a constructor with no arg to fruit, or create a constructor for apple, which the first statement will be a super that passes an argument. One argument. What it is? Trust me, this is out of the context of a difficult question.
I wrote a couple codes involving it, so it's still kind of fresh in my mind. But yeah, I feel you can get mixed up real fast.
Good. A subclass inherits from a superclass. You can also what? Add new properties. Add new methods. You already know how to add new properties, right?
Yes.
Subclass?
Yeah. You
Yeah.
did that, right?
Yeah.
Did I add new methods?
Yes.
Yes. So these two are easy, right?
Right.
We didn't talk about this one. Override the method of the superclass.
I got you.
All right?
Yeah.
I mean, I do got you.
Override means your parent has a behavior. You don't like that behavior, but you still want to have that behavior, but with different implementation. Do you talk exactly like your parents? But do you talk?
Right.
Your parents talk too, right?
Yes.
But it's a different behavior, right?
Right.
Even though it's the same talk, right? You're overriding the talk of your parents. There you go. So, let's take a look here. So, cat. Let's input a method there or behavior. Public, should it be static or no?
No.
No, because it's related to object, right?
Yep.
Public void sound. System out print line. Okay, tell me how your cat make it sound.
Yeah.
Is that good?
That's how one of my cats breaks that.
You can change it if you don't like the sound of your cat, okay? So if I create a cat, which I created, can I call the sound of that cat?
Yes.
Yeah, if I say C sound, then if I run this, you will see what on the console. Yeah, you good? Now, Wildcat doesn't like that one. Because Wildcat makes different sounds. So, if I create a Wildcat, say I create a Wildcat here, right? And if I say Wildcat 1 sound, and if I run this, what do I see on the console? Again, the same behavior of what? Of the cat, right? Now what I do here, I'm going to override the method sound from the parent. I'm going to write exactly the same thing, but I'm going to implement it what? Different way. Is that good? The Wildcat, right?
Right.
if I run this, what gets printed on the console when I create an object of a wildcat? Will it say meow or? Yes, because it will find the one that's related to its class. So did I override the sound method in the wildcat class?
Yes.
If I did, that's override. So does the method, everything looks the same as the parent one? Yeah, it looks exactly the same, right? Now let's say by mistake, you have a typo here. By mistake you made a typo here. Is this method an override of the previous, of the parent one? No, right? And then you come here, you have the hope that you overridden it, right? But when you run this, what gets printed on the console? Right? It can happen a lot, right? A typo. So in order to safeguard that, I'm going to put an and override here. This means make sure you are overriding, and if you're not overriding, I'm going to give you a compilation error. So this is a safeguard. So you see, did you get a compilation error? Yes, because you said override, which means check that 100% you are overriding. But if you put a D with double, a D, two Ds, that's not an override because you're not overriding the sound. Now if I make the 1D, is it an override now?
Yes.
I compile.
It's great documentation too.
It's a safeguarding to make sure you're 100% overriding. Otherwise, compiler will stop you. Because if compiler doesn't stop you, then in runtime there's some problems, right? So which one you prefer, compile problem or runtime problem? You like no problem, I know, but in general, if you know compile problem and runtime problem, you prefer compile one. It doesn't get to production. You can't sell the software when it doesn't compile, right? So we understand and override tag? So are we good? Is override? Alright. So let's take a look at this one. Circle extends from geometric object, right? And geometric object has a get date created. So public void print circle. I say system out print line. The circle is created. Super get date created. Is that calling the get date created of the super class? And then concatenating with what? With this string and concatenating it with the property of the same class. Alright? So can I use super dot? Yes. Which means go to the super class and find this method for me there. Are we good? Alright. Alright, this is something I have to talk about. Alright, override. Let's go to geometric object. Geometric object has a toString method. And I want to override that here. Let's show it in the animal class. Do I have toString here? No, I don't. So I'm going to write what? Public string toString return I am an animal, for example. Alright, we talked about toString before, right? Whatever object you put in a system out print line, it will trigger what? The toString. So if I create an animal object and I say system out print line that animal, it prints what? I'm an animal, right? So let's try that. Well, actually we can try it in the cat class. So did I create a cat object?
Yes.
So C1 is the object reference, right?
Yes.
So can I say system out print line C1 toString, which returns what? I'm an animal. But you can also remove this and automatically cause the toString again. So it's up to you. If you don't put that toString or put it, doesn't make any difference in system out print line. Alright, we good? So if I run this, what will happen?
It won't run, you have two S's in the system.
Oh. Alright. If I run this, I'm an animal, right? Okay. Now in the cat class, I'm going to override that. So I'm going to come here and say what? And override. Now I'm going to write what?
You misspelled override.
Two R's, right?
You put,
Public string to string. Now take a look here. Sometimes you want to override, but you don't want to completely discard the parent behavior. Sometimes you don't want, because it's useful, but you don't want completely to rely on that one, all right? So can I say return super to string, which means what? I'm an animal and a cat. So this means if I create a cat object and I print that cat object, will it print for me the super class behavior of toString, which is I'm an animal, and it concatenates that with what? And the cat. So I don't completely discard the behavior of my parent, I add to it. So if I run this, what gets printed? I'm an animal and a cat. If I create an animal and I print it, what it prints? I'm an animal. So did I override the toString? But did I inside that rely on the parent toString a little bit? Yeah, you can do that.
Can you do cat toString, cat or C1.toString as well? Like if you were trying to do like for raw cat, I am an animal, a cat,
Yeah,
and
we
a
can do that. We're going to do that. Now be careful here, because if you don't put that super here, then there's a big problem. What is the big problem? It takes its toString of which class?
The current
It
class.
comes here, again it comes here, it thinks the toString of which class? This is the subject of recursion we're going to talk, but in this case, will you ever stop? No. And it blows up with Stack Overflow. But you love that site, right?
Yeah.
Stack Overflow. Why do you have an overflow of stack? Because every method call does it create a section of the stack for that method, and again another section, again another section, again another section. Unlimited, right? So it fools the whole stack, because stack has a limit. That's why overflow, stack overflow. So if you don't put that super, it goes with the same method in the same class, but if I say super, it goes to the super class. Are we good? And let's go what Ben asking for. So I'm going to come here and say, and override what? Public string to string. And I would say what?
return
what?
return super dot toString plus
And the wildcat. An animal and a cat and a wildcat. Run it. Oh, because I didn't put that there. So can I say system out print line only? Print line. Or you can put toString. It doesn't make any difference. And it's run it. I'm an animal and a cat and what?
so the toString for the cat.
I overridden the toString in the wildcat. I overridden toString in the cat because I don't like the pure behavior of their parent. Are we good with this?
Just wait till it gets to a radius. You're gonna love your life when you see anyways.
All right. So
Could you go back to
to the code.
Yes.
So you can have
Before you do it.
Cause I gotta do it first, goddammit.
So if you take off the override on account of sound, would it be a count?
One.
No, I think it actually still works. I think you
Good.
said you put that there as like a mental note to yourself that this is an override for a code that exists inside of the panel. Because if you take it away, it still works. Yeah, the and override, that's a mental note, like you said, right? For the like, that's a mental note just to say that this is the overriding code for the one in the parent.
You just make sure you can't mess up.
Yeah.
Like in this bill.
It's not mental.
Well, it's just a note, right? Because it works.
Enforce.
Yeah,
It enforces.
and it forces.
Yeah, it
Oh yeah, it does force you. Yeah, it does force you. Yeah, because if you don't override it, it comes up as an error. It makes you override. Yeah. I understand.
Yeah, alright. And it's helpful because here, look in the wildcat, by mistake, I say toString. Is that an override anymore? No, because parent doesn't have that. But this one will catch that for you. So you're not overriding. You good?
Mhm.
Alright? An instance method can be overridden only if it's accessible. If it's private, there's no point, right? Thus, a private method cannot be overridden because it is not accessible outside its own class. If a method defined in a subclass is private in its superclass, the two methods are completely unrelated. If it's not accessible, you're not overriding because you don't have access to it. Like an instance method, a static method can be inherited. However, a static method cannot be overridden. If a static method defined in a superclass is redefined in a subclass, the method defined in a superclass is hidden. You can have a static method too, and it inherits, but you cannot override the static method. You got
They're
it?
immutable.
Hmm?
They're immutable. I guess those methods, right? You can't change them.
Who is immutable?
The methods.
But immutability doesn't make sense for methods, just for properties, right? But that's fine. Alright, overriding and overloading. You already know overloading, right? We learned today overriding. So, let's look at this class. Class B, class A extends B. Class B has a public void P double I. What about class A? Public void P double I. Is these methods overridden?
Yes. They're same people.
One is in the parent, one of them is what? In the child. Now look at this one. Public void P double in the class A, which is extends from B, public void P int I. Are these two overridden?
No.
So what is
Different
it?
data types.
So what is it then?
Overloaded.
Overloaded. I can call the method P with a double, it triggers this one. I can call P with the int, it will call this one. So can I overload in same class? Can I overload a method in the same class? We did that before, right?
Right.
Can I overload in the parent and child class?
Yes.
That's what we did here, right? Can I override in parent and child? Override. Can I override in the same class? Doesn't make any sense, override in the same class, right? Override is only parent and child, not in the same class, right? You can have same method, exactly the same header in the same class, right? You get an error there, right? So override is for parent child, overload is what? It can be for parent child and it can be for what? For the same class. Are we good? Every slide is an interview question, alright? That's what I said? Yeah, and it's true. You said that from previous class. Yeah. Huh? You have expectations?
No, we kind of like you told us what to expect.
Yeah. Alright, before we go for 5 minutes, let's finish this one. Public class circle, does it have a parent? No.
No.
Java has parent object called object class, which is the parent of every class. So even though this doesn't have an extend, it implicitly is what? Extends object. So every class directly or indirectly inherits from what class? Object class. Object class. Object class is a superclass of every class, directly or indirectly. So, in this, is faculty extending from object to? Indirectly. Is employee extending from object to? Indirectly. Is person extending from object directly? Because there is an extend object here. Very good?
Yep.
So now you understand after what? 5 months? 6 months? That when I say WC1, which is the white, and I say dot, you see a lot of stuff here. Where are they coming from?
Object class.
Object or cat or animal, but you would match one of them from these classes. If it's not animal, if it's not cat, it's coming from where? Object. Long time.
Yeah.
You get me, right?
Yeah.
Alright, so now you understand. Alright, let's have a couple of minutes break and then I explain the object class. Alright.
Part 2.
That sounds very useful. Cloud is where it's at.
Alright, pay careful attention in the next hour. It's very important. This part is extremely important and a little difficult to, alright?
We're still on chapter 11, right?
Yeah. I want to finish 11 today.
Not that bad.
Hey, I'm still doing AIS.
Polymorphism is a
You go to
little.
that last debate?
You know polymorphism?
No.
I mean, I'm on chap.
I haven't been on one yet.
You know polymorphism?
I was trying to get really involved with it. Get involved
Is
with
that
it.
when, because it occurs at runtime when you create an object, right? So like if you're trying to, so if we say object X is equals to class or an object that you created. So object is the data type or whatever.
Yeah, I need to pay my
Object
dues,
A
bro.
equals
Like, I
to
would-
new
yeah.
cat, right? It doesn't know what
I will.
it is until runtime.
Yeah, I think the
It's-
voting is like, it's gonna be something.
I know, I'm like,
No, you're right, but that doesn't give you the whole picture of polymorphism.
so I'm
This
just,
is one part of polymorphism, right? That's what I'm saying.
I'm fired. Okay, so
Exactly,
I'm
yeah.
just,
Because
I'm
like,
not saying like I'm good.
the bigger
I'm
chapter of
getting it,
AIS is like nationwide, right? Yeah, so
right? I got the basic thing.
You're right.
that's a lot.
Wait,
Alright.
isn't that when methods though? Because if you try to put the object in there.
Yeah, you have to have methods to show
Right.
different forms. That's fine.
Yes.
Alright.
You like the job?
So we know public class circle extends the object, right? Now object is very important class because every class inherits from that. So let's talk a little about couple of methods in object. So object have couple of methods and important to know those methods, so I'm gonna explain. Let me go to animal. One of the one of the important methods of the object class is toString. Another one is equal. Another is hash code.
You said under object, right?
Yes, so see here, if I come and say C1, do I see equals?
Yes.
Do I see hash code? Do I,
Under object.
do I see toString? They are all coming from what? Object. So we have to understand at least the behavior of these three that's coming from the object class, okay? Now let me go to animal. Let me remove this. And let me go to the cat class and let me remove this. So do I have cat object right now? Yes. But can I still say system out in C1? Yes, because toString gets called on this object, right? But I don't have a toString in the cat, I don't have a toString in the animal. So toString is coming from where? Object. So if I print this, so let's see what will happen. It tells you what package it belongs to, that object, what is the class of that object, and it gives you a unique identifier of that object. That's the default behavior of what? Of toString of the object class. Is that too helpful for a business application?
No.
They don't care about the package and the address of the object, right? They want something more descriptive, user-friendly. So do you want to override the toString of the object class?
Yes.
Which I did, right? So when I did that, what would you get on the console when I ran it? I'm an animal, right?
Yes.
Okay, so here you go. I'm gonna say,
You deleted it, didn't you?
yeah, I did. I'm gonna put it back. So am I overriding the toString of the object class here?
Yes.
I have a problem here because let's just say I'm a cat. So if I go here back again and run this code, will it call the toString? Yes. But does it call the toString of the cat class or the object class?
Object. I don't know. I'm
I
guessing.
have the toString here.
Oh, and it says over.
When you have a toString in the same class, why didn't you go to this toString of the object class?
I was guessing wrong.
No, if toString is already in this class, we're going to use it.
Yes.
If it doesn't find it, it goes to the parent and then parent of parent, right? I have a toString, so did I override the toString of the object class?
Yes.
In most cases you will do, because the toString behavior of object class is not desired for business applications, right? So do you understand the behavior of the toString of the object class? It means the package, a class name, and some unique identifier, right?
Yeah. Right.
Now let's go to the equals. Cat1, Cat2. Are these two references to an object?
Yes.
Are they the same reference? No. So what gets printed here?
True.
False.
Oh, false.
False.
I'm comparing the references, right?
Right.
Are they the same reference?
No.
No. So it prints what?
False.
False. False?
Right.
All right. Now, let's say I create, let me create another person, student. Always make mistakes.
Yeah, I type the same exact thing.
Yeah, exactly. For many years I do always this typo. Alright, student. Alright, so student, give me a couple of property. Let's say private string name, private string SSN, private string email, and so on, right? Well, I have getters and getters, setters, right? So I'm going to create this So we good?
Yes.
Alright, now take a look here. Can I put public static main here? Yes, right? Public static void main string. Now, I want to create two students. Student S1 new student, and I'm going to create another student. And I can have a constructor, public student, let's say string name, string SSN, string email. So any questions so far? No. Then I say what? This name, this SSN, this email equal what?
Name, SSN, email.
two students with Tom. 1, 2, 3, 4. T@gmail.com. Good. Now, if I say system out print line S1 equals S2, we get false, right? Now, default behavior of equals in object class is exactly what you see here. So if I come here and say system dot out print line S1 equals, which comes from what? From object class, right? S2. What gets printed on the console? It's exactly the same behavior as this. The equals method of object is exactly the same behavior as this.
Is there a different?
It compares the references.
Is there a different way you can compare?
Hold on, 1 second. Do we understand the equals behavior of an object class?
Yes.
It's exactly comparing the references. Right?
Yes.
So if in the interview they say, what is the behavior of equals of object class? It is what? Exactly like equality. Now, in the business scenarios, in the business application, when two students having the same name, having the same SSN, having the same email, are they same students? In business application, yes, right? But do you get ever true for this call, equals S1 equals S2? So is equals behavior of an object desired here, or it's not desired? It's not desired. I don't like it because I like to compare the content. I don't like to compare the references. References in business application doesn't mean anything. Reference is technical programming thing. So, am I going to override the equals method of an object and add the behavior that I would like? So I come here and say, I don't like this behavior. By the way, if I run this, I get false for both. Do you agree?
Yes.
Alright, false, false. Because it's the same behavior, right?
Yes.
Now I'm going to come here and say what? And override. And I'm going to say what? Public. You have to know the header. Boolean equals. And we'll say what?
String SSN and then email.
Not string. Object.
Oh, here comes the 25.
Now this is a little bit complex, so as we go I explain so everything gets clear. So object. Can I have object OBG? Because object is a class too. Can I have cat OBG? Can I have wildcat OBG? String OBG? Yes. Object is the parent of everything, right? So I can say object OBG, right?
Yes.
Now take a look here. The object I'm passing here is what type?
Student.
It's a student, right? Now take a look here. If I say OBG, is that an object of an object class?
Yes.
If I say dot, do I get anything about student? No. Compiler says, this object is matching this class. I can only see the methods of this class.
Because it's a parent.
No, because it's an object class,
Oh, okay.
right?
Yeah.
You agree? Right. So, before I explain that part, I need to explain this part a little bit, alright? So, keep a marker here, just don't forget that. Now take a look here. Object OBG. Is that a reference? Yes.
Yes.
Of what type? Object class. Where is pointing right now? Nowhere.
Nowhere.
Nowhere, right?
Nowhere.
Okay. So, now let me say cat or student. Alright, so you have it here, right? Here you go. Student S3. This is easy to understand, right? Now, in inheritance, always think like this. Wildcat, cat, animal. Is a cat always an animal?
Yes.
Is a wildcat always a cat?
Yes.
Yes.
Is a wildcat is always an animal?
Yes.
So can I go to the chain from bottom to top easily?
Yes.
What about top to bottom?
No.
Is an animal a cat?
Yeah.
Not always.
Oh, no.
Not always, right?
Yeah, not always.
But is a cat an animal always?
Yes.
Always. So let me go here. Can I say an animal is a cat?
Wait, can you say what? Animal?
Animal A1 equals to cat.
Yes.
Yes, even though you might say this reference is an animal type, this one is a cat type. In inheritance, you can assign a child to what? To a parent data type. Yes.
You can only do this in a child class, or can you do that in the parent class too? Like in a parent class, can you reference a child class?
If you can create one there, but I can't. Okay, you mean here?
Yeah, like could you reference like cat or
Okay, I can put
C1?
a public static void name string target. I can say animal A1 new cat.
Oh.
As well as those classes are visible, yes, that's fine.
Oh.
So can I put, let's go back to the cat. Can I put an object reference of a child in a parent?
Yes.
But,
You can't put a parent object inside a child.
no, hold on. Compiler checks. Compiler says, this is a child class, this is a parent, I'm okay with that. But, what is exactly this reference pointing to? Is it really pointing to an animal or a cat?
It's both. The cat.
Did I put a cat inside this?
Yes.
So is this really pointing to a cat?
The reference of the cat. Yeah. the
Yes,
object.
right?
Yeah.
But I wrapped it around with an animal, right? So what is really inside this object is what? A cat. Okay?
Yeah.
You everybody agree? It's a cat?
Yes.
Now take a look here. Cat C3. Compiler does not like that. It says you are trying to put an object reference of an animal to what? To a cat, and I don't like it, I will not let you compile. But you will say, I put a cat inside this, so I know this is really a cat. It's not really an animal. So you have to make compiler happy, and you say, I'm gonna cast that to a cat. And compiler says, okay, as well as you know what you're doing, I will let you compile. But if you're doing something crazy here, even though I'm compiling, but it might blow up during the runtime. So, did I put a cat inside this?
Yes.
Is that really a cat?
Yes.
And I put that back again to a cat and assign it to C3. Yes, this is with the condition that you know exactly this is a cat and you are converting it to a cat. Yes.
So if it had like non-cat properties, then it would be like a runtimer? It would be a runtime?
Which one non-cat property?
Like say it had properties that could not fit in a cat, in the cat
No,
class.
I know what you're saying. You're putting the question in the wrong format. So let me say this. Let's say wildcat. Let me create a wildcat. Okay. Wildcat equals W1 equals new wildcat. Can I create a wildcat? Yes, right? Is wildcat an animal too?
Yes.
Is it? So compiler is okay with this. Compiler always okay, you assign a child to a parent. We good? Now you say, A1 equals to cat. Oh, my bad. Let me go in the same example. C1. So we go here, right? I assign the cat to an animal. That's fine, right? Now take a look here. Wildcat W1 A1. Compiler says I'm not okay with this because you're trying to put a reference of an animal to what? To a wildcat. You cannot go down. You can always go from bottom to top, right? But you say, I know what I'm doing. This is really what? A cat. It's a cat. But by mistake, I say, convert that to a wildcat and put it where? Inside this.
Yeah.
Compiler says, okay, I'm assuming you know what you're doing, but can I convert this one, which was really a cat, to a wildcat? No, not every cat is a wildcat, right? So it is compiled, but during the runtime, it blows up with the class cast exception. See, that's the part which is dangerous. It leaves that to the programmer to know what exactly you're doing. Compiler will check if you go from child to parent. Compiler also check if you go from parent to child, but you can say, I know what I'm doing, just convert that to the child. And this only it will be successful if you really assigning something of this type to this. This is not a wildcat type, it's what type? The cat type. So you can cast an object reference from a parent to a child. In the condition that the parent one really is a child one. If it's not, it blows up. Alright? See, you can do a crazy stuff here. String. Do you know string class?
Right.
Can I assign a cat to it or an animal to it, A1? Compiler says, what the heck you doing, right? But then you might say what? No, actually not this one because it's not in the same hierarchy, so you can't do that. But let me do this one. No, it's not in the one hierarchy. Forget what I said. Right? It's not, it should be on the same hierarchy.
Got it.
So, you can go always from child to parent. From parent, you also can go to child, but you have to cast that and you have to make sure your cast is correct cast, which means what is exactly in A1 matches this. Now take a look here. I'm going to create a wildcat here. Wildcat, new wildcat. And I'm going to put W1 here. Is that okay?
Yeah.
You can always go from wildcat to animal, right? Cat to animal, right? Now take a look here. Can I put here instead of a wildcat, cat?
Yes, because the wildcat has all the properties of a cat.
Yes, I didn't go directly to a wildcat even though I put a wildcat here, but I can convert a wildcat to what also?
Cat.
To a cat. So it's acceptable. Okay?
Yeah.
Okay. So we good with this casting? So casting, is it a runtime problem if it blows up or is it a compile time? Runtime. Compiler cannot check that. It says, okay, cast it, but it's your responsibility to make sure it runs.
Got it.
So we good?
Yeah.
Now, take a look here. So I'm going to comment this. Is object the class, parent class of every class in Java?
Yes.
Is that true?
Yes.
Yes. So if I say object obj, can I put any reference I want on the right side?
Yes.
Doesn't matter if it's a string, if it's an animal, if it's a fruit, anything.
It's not supposed to, yeah.
Yeah. So you see the power of object class? it's a class that I can assign any object to. So now you understand why the equals, where did I go? Was it the animal? Or student. Now you understand why when you have equals of the object class, this is object, because I can pass the student to it. I can pass string to it. I can pass anything to it. But in this case, in my student case, what do I pass to it? A student, right? In the class of equals of a string class, do you remember equals of a string class? What have I passed to it? A string, right? So, when I call this, so when I come here and say S1 equals S2, am I passing a student? So does that student comes here, which is okay, right? But what is exactly inside that? And student? A student, right?
Yes.
So can I come here and say student S1, cast that to what? To a student. You good?
Yeah.
Alright. So I got that student, which is this one, right? And how can I get this one? You already have it, right? Because anybody who calls this, that's this, right? This is the S1, right? This is the S1, right? Alright, so I come here and say this, get name equal S1 get name. Alright, you can do AND here for social security and other stuff too, but let's simplify it for now to save time. So what I did here, I overridden the method of equals of an object. I get a student here. Of course, I have to cast that to a student, because if I don't cast it, I don't have access to get name. That's the reason I'm casting it, because if I just rely on an object, I don't have a get name on it. Now I'm comparing the object of equals, which is S1, with which one? With the S2 that I passed. If I say the names are equal, what to return? True. So did I overridden this? So now when I call S1 equals S2, does it trigger this one? Will it compare the names of S1 and S2? And will it now return false? True.
So it's going to compare the names regardless of the number of strings that you pass through the argument?
Yeah, it just compares the name. You can compare also the name on SSN and also email address on the same method. But I'm just trying to simplify it. So you see, I don't rely on the equals on object because that compares the references. What I'm doing here, I'm overriding it. I'm getting it as object, but I know I pass a student to it, right? I convert that to a student, cast it to a student. I get the name of that student with the name of what? The student S1 here, right? If they are the same, I say they are equal.
So you wrote the equals method on the bottom and the line 42 on the top. Is it going to take that equals or the original?
You tell me which one it takes.
I think the newer one.
Yeah, because it looks in the same class first. Do you have equals in this class?
Yes.
I have it. So why you need to go to parent?
So at that point, you're passing the string in S2 inside the method.
It's not a string, it's a student object.
A student object.
But it comes in this object, so what is really inside this object? A student. So can I cast that and having no problem during the runtime?
Yeah.
Yes, I can.
So
Now, someone can make a mistake and say string. String. Will it work during compile time?
Yes.
Yeah, it says you know what you're doing. You're casting that object to a string, but is this object really a string? No, it's a student, right? So this part is a danger on the programmer side. You should know what exactly you're doing, casting.
Yeah.
So when it says this dot get name is equal to S1 dot get name, I
Sorry,
thought
one more
that
time?
when it's saying this dot get name is equivalent to S1 dot get name, it's comparing the references, not the content. Or is it,
Are you talking about this one?
yeah, is that comparing the content or the references?
You tell me, comparing what?
I thought
Comparing
that.
the name of this object, this, with the name of this object.
I thought the equal sign was comparing references, right?
No, it compares this side with this side.
So it's comparing the content.
Depends what you put there. Are you putting a reference in the left side or a content on the left side?
Oh, I get what you're saying. So.
What you
on
putting
there,
here?
That's mostly what it's.
You-
That part there, it says get name for the content.
I mean, yeah. I mean, they're both.
No,
giving,
no.
They're both giving you back strings, right?
This is a string and this is a string.
Right.
And you do what?
Compare the two. So you comparing? Are you?
Oh,
You compare?
hold on. Actually, you're right. That was my mistake.
Okay. So they are comparing the references, right?
Okay, hold on. I made a mistake here. Because strings are references to, right?
Right.
I should not put the equality here because this compares the references.
So it's gonna
right?
give it back false, right?
It returns false, right?
That's not a problem.
So I have to put what here?
Dot equals. Right?
Correct. You're right. You good?
Yeah. I thought it was shit, right?
Right?
Yeah.
If you get the string and compare it, you compare the strings, right? References, right? So you have to say equals because equals of string compares the content, right? You good?
Yeah.
Now someone tell me this, you get a bonus
Uh-oh.
if you answer this.
What kind of?
I didn't say what is the bonus, I just
Just
said
said
the bonus. I put this there, right?
Right.
But I still got true when I ran it. Why?
It's the thing where it's the internat strings or internat it's internat something. What is it? You know what I'm talking about?
Intern.
Oh, is it
Intern. He was saying internat. I swear he was saying internat.
Intern, right?
Is that just the accent?
Internet.
Internet, yeah. What is it? Strings or references?
Because
Yeah.
Tom and Tom
Are the
are the
same.
I
same.
said that.
girl.
I said that. I said that. Give me my bonus.
Yeah, I get a bonus.
I have to share your bonus. With me.
We can split it.
That was the only reason it was returning true because Tom and Tom have the same mutual. Even though you're comparing references, but because we're pointing to the same mutual, they will have the same reference. But see here, if I make that new string,
It's different.
then it will not return true anymore. It will return what? Here we go, false. And then if I make that equals, it returns what? Now it returns true because it doesn't care about the references. It cares about what? Content.
Like an added 10 points on the next quiz or something.
Monetary bonus.
You didn't answer.
Yeah, but you
Gotta
said
hit the student account.
Well, at least give us that 10 points.
You negotiating for those?
I'll negotiate for me.
I never use one.
Alright, are we good with this?
Yeah.
That wouldn't be fair.
Alright, you have to practice stuff. It's not, they are not very, very easy, but it's easy if you run a couple of codes.
Yeah.
So are we good about equals?
But he was saying.
Yeah.
Why do you need to override it? Yes.
To the object.
For the exam, would you say it's better to study
Yeah, if it
more
was object
1 through 8 or 9
Then
through
we act like
8?
equal sign.
All of them.
All of them?
Oh wait, chapter 12 is gonna be on there too.
Sorry, what?
Chapter 12 is gonna be on there too.
What?
No, it's just.
Did you say
You're
one?
only gonna hit 11.
I figured, oh yeah, 11.
Today is it.
Yeah.
Oh yeah, if I finish 11, I'm not gonna ask 12, right?
Right.
So 9 through 11.
Unless you think I'm crazy. Right?
1 to 11.
Alright, so we got the equals?
Yes.
So in your project, if you have customer, you have ticket, you have all this stuff, do you wanna override equals or no?
Say it again.
Let's say you have a ticket
Yes.
class.
A ticket class.
Or you have customer class. Do you wanna override equals in your
Yes.
business scenario?
Yes.
Yeah, because two tickets, doesn't matter, references are the same, no, can be the same, right? Can be true, right? When you say equals, right? So we good?
Yes.
Now, what is the hash code? We talked about hash code too, right? We did not. Don't worry too much about it. Hash code, if you apply hash code to an object, if the object have same references, it will give you a same code. If they have different references, they get what? Different
But
code.
it could be the same because that's what there's only finite
Don't worry about that part.
Alright.
Just listen to me.
No hashing blockchain.
So, when two objects have the same content,
It's the same hash.
but two different references, when two students has the same content, but two different references, hash code will return what?
Two different codes.
Two different codes.
Yep.
But if you override equals, which means you go content based,
Same.
you have to also override hash code to go where? Content based. Alright?
Yeah.
So, interview question. If I override the equals, do I need to override hash code too?
Yes.
Yes. Because hash code of two objects that have same content, if you override the equals, also should return what? One code for both. Alright? But we're not going to override that, don't worry about it, but that's the norm. But we already understand the equals, why you need to override the equals, right? Yes, right.
Actually, I still have a question about that. So when it says that when equals as an object method behaves like the equivalent,
Yes.
what's the difference between like the equals not as an object method and like so those two,
These two, this one, and the equals of an object class act the same.
right.
So this means if you use the equals of the object class, it compares only the references.
Right, so it's comparing S1 and S2
Yes.
as a whole, but in the second part, it's comparing the two strings that they kick out.
Here, it doesn't care about the reference. It
Right.
says, when I get one reference here, and I have another reference, I'm going to compare only what? The content of the names. And if they are equal, which means they have the same name,
Right.
regardless if S1 and this has two different references, I'm going to return what?
False.
True.
Right. True, well, true.
Yeah.
But like, is it different because of how you call it or where you call it, or where you do the method? Like,
How you call this?
yeah, like is it because like you're calling equals inside of that method right there? Like if you called it outside of that method, would it behave differently, or like what makes it
If
behave?
you call the equals of any student object
Mhm.
or any child of the student, it will trigger what? This
That
one.
one. It's gonna trigger that one.
Yeah.
Right.
That's inheritance, right?
Right.
If anything is above student and doesn't have an equals, when you call equals, it calls which one? The object class. See, whenever you call equals on any object, first you see, do I have equals in that class? If yes, trigger it. If no, where I go? To parent. Do I have it in the parent? Yes, trigger it. No, where I go? Next parent. You keep going until you find it, right?
Yeah.
And what is the last destination? Object class. And if even you don't find it in object class, then what will happen? You get a compilation error because you have to have it somewhere.
Yeah. So in the second instance that we use the equals method, we're calling it this coming from the object class. Like
Which one?
down in the return this dot get name, is that going to the object class?
This one?
Yeah.
This equals one? This goes to the string class.
The string class? Oh, because there are two strings on the end?
Yes.
Okay.
And give me a guess. Do you think string overriding equals method or no?
Is it overriding it? Yes.
Yes, because it doesn't compare the reference. It compares what?
The string.
The content.
The content, yes.
So string class has overridden the what?
The object class.
The equals of the object class also. Yeah, because if it relies on what? If it relies on the object class, when you say string 1 equals string 2, it will only compare what? The references, not the content. So string classes, I don't like this behavior. I'm going to override the equals of the object and I make it content based again. Content comparison. Does that make sense? Yeah. Go ahead.
So you just kind of confused me with the hash code thing because.
Don't worry about hash code right now.
Alright.
So that means don't worry about hash code for the exam?
For exam, don't worry, but for interview, worry.
Okay.
So can I ask you after that?
Yes. Alright. So let's go through here. So two string method in object. Can I create a lone object that we had before? Do you remember lone object? Lone class? If you don't remember, we had a class called lone interest and blah blah blah, right?
Yeah.
Can I create an object of it? Yes. Can I say lone toString? without having toString in the loan class?
Yes.
Yes, this toString comes from where?
Object class.
Object class, and print this for me. This is not useful. Maybe you want to say, this is the name of the borrower, this is the interest rate, and blah, blah, blah. So should I override the toString method of object class inside the loan class?
Yes.
And put whatever I want?
Yes.
All right. Yes.
Where can we find all the methods inside the object class?
Where?
API.
Is that what the
API.
API is for?
Here we go.
Jesus, so it's like unlimited permission.
Java 1.8 or 1.9 or 10 API, and you go here and you see the object class.
You have to import them? Which one are the ones that you don't have to import?
Look at this. This is part of what?
Like,
Do I need to import that?
no.
All the ones you don't have to.
All right. Do you see clone? Do you see hash code? Do you see where's the equals? Equals? Click on it. It explains to you how it works. It's exactly what I said. It compares the references. See? If X and Y refer to the same object, has the value true. So it exactly does the comparison. So you have everything, right? And you will know more because let's say scanner.
That's why we don't.
Let's say, where is the scanner?
What's your James
Okay. Scanner, it belongs to which package? Util, right? What this means? Scanner extends what?
Object.
Object. If it was more than one object, you will see more here. You will see that the chain indented. Let me click on one and select one. Oh, here we go. Split the exception extends from exception, exception extends from trouble, trouble extends from what? Object. So you will see top part over is what?
Object.
Object. You see this now? What it says? Extend, exception. Does it match this?
Yeah.
There you go. And then if you want to see what is inside this, you see everything here. But there are more inside that, right? Because all of them coming from where? From this one, from this one, from this one. You got it? Alright, now let's go polymorphism. We have 20 minutes. If you understand that object and object casting, polymorphism is easy to understand. First of all, polymorphism, it means different forms. Poly means different, morphism is form. That's a Greek thing, alright? Alright. So it means a method will show different behavior during the runtime based on what you passed with. Different behavior during the runtime. So let's take a look. This is an example of polymorphism, but you have to elaborate in details about polymorphism during the interview. Because it's a bit confusing to explain and make sure the person who asked the question understand polymorphism, right? So polymorphism, first I explained this in different forms, and the only different forms that Java supports is dynamic binding. Dynamic means runtime, binding means that object binding happens during the runtime. So I'll give you an example and it's clear what polymorphism means. Take a look at this method. First of all, I have a public class polymorphism demo. I have a main here, but I have a method here called what? Public static void m object x. Can I call toString on x? Yes, because object has the toString, right? Compiler understand only what is this. It says, okay, you were saying object, toString belongs to object, I can call it. So we look, you see this? Right. Now, we have graduate student, which extends a student class, and there's nothing inside that. We have student, which extends the person, And what is inside the student? ToString, which returns what? Student. Did I override the ToString of the object class? Yes. And then you have a person, which you already know extends from the object. Putting this or not putting it doesn't make any difference, right? And I'm overriding again ToString, and I'm returning what? Person. What about grad student? Did I override the ToString in grad student? Not directly,
It's in the
but
student.
it's inside the student, right?
Yep.
So if I call ToString on a grad student, which ToString gets triggered? The student one, direct parent, right? Direct parent, right? Are we good? Alright. Now I'm calling M with different object types. One with grad student, one with what? With student, one with person, and one with object. Can I do that? Yes, because anything that I put here is the object type. It's object type, right?
Yeah.
You agree?
Yeah.
But if grad students come here, X2 string from compiler perspective is the toString of the object. But during the runtime, dynamically, the JVM understands what is the exact X reference, and it calls the toString of that related object. Which means, am I passing grad student here? Yes. So during the runtime, does it call the toString of grad student? Yes. What about if I call student? If I say toString, will it call the toString of the student? What about if say person? What if I say object? So during the runtime, it exactly knows how to bind the object and call the right method. Is this a runtime behavior? That's why we call it dynamic, right? And that binding happens during the runtime, right? So what you see, you say all the methods you will see from now, it will be object as an argument, because you can pass anything to it. And when you trigger a method, during the runtime it knows what did you pass exactly, and triggers that method on that specific object. What is the benefit of it? There's a lot of benefit. Why? Because if I didn't have polymorphism or dynamic binding, how many times I have to write this method? One for grad student, one for student here, one for person here, and one for object here. But during the runtime, it knows what is exactly this object and triggers the toString of that related object during the runtime.
So if you were to pass a grad student object to it, would it just run the toString of object since grad student doesn't have one?
But student has one.
So it would go to student?
Yeah, that's the case. If you don't find the method in that class, you go what?
To its
To the
parent.
parent. If you don't find it in the parent, you go to what? To the parent. You keep going until you get to what?
Object.
Object.
Okay.
And if you don't find an object,
It's a
compilation error, because they should be there.
Okay.
Are we good with this polymorphism?
Mhm.
Now make sure you can elaborate 5 minutes in this during the interview, or 3 minutes. Because if you say the reference of object, and then when you run it, and then you don't explain it properly, they don't know you know it. So they say you don't know polymorphism, right? Maybe you can give this example.
Yeah, yeah.
So you see this? You see this? This chain we're talking about. If I call toString on C1, if it doesn't find it here, where it goes? If it doesn't find it here, it doesn't find it here, until it gets to what? The object. So here I'm fine, because I know toString. It's on the object, I can call it, and all of them will have toString directly or indirectly, right? So is it a good idea to put the argument as an object or a specific class? Which one is better?
Object.
Object. It makes it more generic programming, right? We good? See here, can I come here and put here student? If I put student, can I pass an object to it? Yes. Can I pass a person to it? Can I pass a student to it? Can I pass a grad student to it? Grad student, no. Oh, sorry, my bad, my
You
bad.
did it backwards.
Backward.
Yeah, I was gonna say, I'm saying. no
Yeah,
to
yeah.
objects, but
If you
that's-
put student here, can I pass grad student?
Yeah.
Can I pass a student?
Yeah.
Can I pass a person?
No.
So there's a problem. Which one is the most generic one? put it as an object.
The
You can
most
pass
what?
anything to it.
Oh.
Agree?
Yes.
Because anything is an object, right?
Just let your brain explode for a minute and then I'll try to make it sense.
Alright. Okay, so you already know about this. Now, casting object. Can I say object only in student?
Yes. Yes,
Yes.
you can. Trust me.
Yeah, everything is an object. Can I pass that O to M method that I just showed you?
Yes.
And toString of what gets triggered?
The student.
Correct. Because in reality, O is what? The
Student.
student. Why casting is necessary? So object, can I assign object to the student? Is that okay?
Yes.
No. Compiler says
What is-
these are not the same type. You're going from parent to the child
Okay.
unless you know what you are doing.
Yeah, yeah. That's what I meant. You could
But
cast it,
this does not give you guarantee that it will run.
Right.
You should have to make sure that, huh? Yeah, it just bypasses the compiler. Compiler says, I'm okay, you know what you're doing. But I don't guarantee that cast will succeed during the runtime.
Yeah.
Unless it is really a student object. Alright?
Mhm.
Or under the student, the child of a student, right? Anything under that is okay too, right? So if I have a fruit, which is the parent of apple, can I say apple X apple fruit? Can I say orange X orange fruit?
Yeah.
But one of them will fail, right? Because the fruit cannot be apple and the orange at the same time, right? You have a fruit and you have an apple, you have a what? Orange, right? So that fruit in reality can be apple or orange, right? Based on the hierarchy, right?
Mhm.
You agree?
Yeah.
Like apple would be the wrong one, right?
I don't know what is the fruit. What did you put in the fruit? Did you put an apple or did you put an orange? This casting will work during the compilation. It says it's okay. Okay?
Mhm.
Now instance of. Instance of is a keyword. So let's talk about this equals. It makes sense here. Alright, did I write equals?
Yes.
Did I override equals of the object class? So I'm getting an object and I'm casting it to what again? To student, because I know people who use these equals here, they possibly pass what? A student, right? But someone might do something wrong. He might come and say, S1 equals did it compile? Yeah, because why? Because this comes here as an object, and object is accepting everything. And then you casting to the student, which compiler says it's okay for me, but it might not succeed. And here it will not succeed, right? So people can do some crazy stuff like that, right? Everybody agree I can do this? Yes, I'm doing it, and it compiles. Will it blow up?
Yeah.
It blow up, right? In order to prevent that from blowing up, I use the keyword instance of. So before I cast it, I will say if obj instance of what? Correct. Then go ahead and do what? Do the casting and return what? Again, I don't understand. Do the casting and return that comparison. If someone passes an object that is not a student class type, what should I return as a comparison? What do you think I have to do? If you want to compare a table with a fruit, what should I return?
False.
False. That's it. Because the object is not type of a student, and trying to compare a student with something that is not a student. Just return false. So now, if I run this, this will not blow up. This will return what? Returns false. While before it was blowing up because the cat will fail during the runtime. So what is the instance of keyword used? Is this object of type of this? So it returns true or false. So if I have an object of cat, is cat instance of animal? If I have wildcat object, is wildcat instance of an animal?
Yes.
Instance means not direct parent. It can be indirect parent too. Very good. See, I have to make sure that I'm casting something to a right thing. Because you never know, someone can pass an object which is really not castable to student, right? Which I did, right? I passed something which is not castable to a student. The more preventive measure you put there, it's better code. You can break a code, it's not a good code, right? Alright, let's see what's left and what we have to conclude.
Wait. Can you go back? One second.
Yes, I'm going to talk 2 minutes about project. You're not going to do it, I'm sure, before the midterm, but let me explain it. Maybe you can go home and read it, and then next time you can ask some questions. Ask me some questions. But 1 second, let me see where we are. Equals, we talked about equals comparison. Okay, we stopped here.
It's the best thing.
Up to 41. So I will cover chapter 11 in the midterm, but up to page 41, slide 41.
Hey, Rayless is great. Read about them at home. You want to do stuff? Using the Rayless. Bumper regular.
Now your projects. The project, you can read about it. It's no big deal. It's crystal clear. Just read what I'm asking to do. There is 3 components to this one: a GUI, user interface buttons, and all those stuff. A Java code and a database part.
Chap10.
Okay.
Yeah, you're gonna use Java. I didn't cover it yet, and possibly I'm gonna send you some videos to look at it. Because when you learn this stuff, other stuff is just how I can draw a circle, for example. You create an object of that class, and then you say draw, it draws. I don't need to explain about this stuff. So with a couple of videos, you can figure out. So there is a GUI, and it's an airline reservation. So you're gonna put the data in that user interface. I wanna have you use the I don't know, Expedia or any Priceline or whatever.
Yes.
You say I wanna go from here to here. You say which city, what day. You click OK. It gives you all the option of the flight, right? And then you book one, right? And then that's it. It has in your account. So next time you log in again, you will see that flight in your account, right? That's what you want to do, but it's not web application. It's a standalone application. Everything is on one laptop, running on one laptop. It's not a browser based. Which means when you run the Java code, it runs it here, not browser based. You see it from a database, what is inside the database. You book your ticket, and that's it. So you log in, you do everything that you can do to that web application, but through a standalone application. So if you read this, it explains to you what you have to do, but we're going to discuss it after midterm again. So what you can do is, you can read this, understand at least what is the business of it. Anything that I didn't mention here, you can assume. You can make an assumption there. And then, any class we have here, anything about the business you see, you can make it a class. For example, when I talk about airline reservation, do we have a customer there? Should I create a customer class? Do I have a ticket there? Do I have a flight there? So can I make classes of all this stuff? Now, should these classes collaborate with each other? Yes, then you can say customer can reserve what? 0 to many tickets, right? Or 1 to many tickets, right? And then you put an array of tickets what? Inside the class. So you can create all these classes with their association. If you need inheritance, use inheritance. For example, admin user. Is admin user extends from a normal user? Yes, because it has everything a normal user has and has some more to it, right? So you can come with all these class creation and writing the setters and getters, and then we discuss more, right? GitHub, it should be there. Without GitHub, no grade. I have to see whatever you do in the GitHub at the timestamp. Who did what? And you have to sync your code through the Git on your laptop. Someone push and pull to the GitHub, and someone pull and push from the GitHub again. So you don't share through email or flash drive. There is one central place that everybody can access and update their laptop with the latest code. If someone messed up the code, you can roll it back. Here you go. So next time, midterm, up to slide 41 on chapter 11. 1 to 11.
Up to, not including 42.
I know, right? Some math, right?
So